To find the percent yield, you first got to find the theoretical yield. The theoretical yield is going to come from the limiting reactant. Okay? To find the theoretical yield, all we need is the smaller of these two numbers. Both of these are finding the amount of iron 3 carbonate. The smaller of those two numbers is the theoretical yield. So in this case, this is the theoretical yield because it's the smaller of the two numbers. Right. Okay. The theoretical yield always is calculated from the limiting reactant. Reactants are on the left side. That means that this must be the limiting reactant. Okay? By definition, the limiting reactant is the one that runs out first in the equation, or the reaction. When it runs out, the reaction stops. So that's our theoretical yield. The smaller of these two numbers. You start with one reactant, you calculate the product you're looking for. You start with the other reactant, calculate the product you're looking for. Same product, same stuff, iron 3 carbonate. With the smaller of the two masses, that's going to be your theoretical yield. Okay? Now the question doesn't end with finding the theoretical yield. The question asks you to find the percent yield. Okay? To find the percent yield, you must also know one more thing, and that's the actual yield. Well, the problem tells you the actual yield. It says that you have 8.27 grams of solid product. If you collected 8.27 grams of solid product, like you guys in the lab today, weighed out the amount of product you got, okay, you have 8.27 grams of solid product recovered. That is the actual yield. Actual yield. Okay? If you know the actual yield and theoretical yield, percent yield is super easy because it's a percent. A percent is always the same thing, part over whole times 100. Part over whole times 100, that's a percent. You got it. There you go. If you'll just remember that any percent is part over whole times 100, it should be easy to figure out percents every time. Okay? So our part is 8.27 grams of the solid, and we identify the solid as being iron 3 carbonate. It says so right here. There it says S here. We figured out what was going to be the solid or aqueous products. We found out that's the solid, didn't we? So when it says 8.27 grams of solid product, it must be that stuff. Okay? It's in your problem. When you wrote down problem number 1 earlier, didn't it say you were going to collect 8.27 grams of product? Okay? So all we have to do then to find our percent yield I'm not capturing anything yet, am I? I don't need to capture this part. Yeah. Oh, I'm capturing. Okay, yeah. All right, got it. All right. Percent yield is any percent is part over whole. Okay, so we've got the actual yield is our part. Over the theoretical yield, that's the whole. Okay, and you take that, when you do division, it's called a quotient, right? And you multiply that times 100 to get the percent yield. So we have to take 8.27 grams, 27 grams of Fe Fe2CO3, close parentheses, 3. Put that over, what is it, 10.79? Fe2CO3, 3, and multiply times 100. Okay? Now watch really, really carefully, guys. Units and species are going to cancel. If you set it up right, any percent will be unitless. If you set it up right, any percent will be unitless. Not necessarily species-less, but it will be unitless. Okay, so all we have to do now is the math. I should be hearing little clicks on the calculator where everybody's doing this problem. Okay, 76.6450,417. Mine goes to the 1 there, and that's the percent. But we have to find the significant digits here. Okay, how many significant digits do we want in our final answer? This is a division problem. In multiplication and division, you look at all the measured and calculated numbers, find the one with the least digits, and write your final answer to have that number of digits. 3 digits. So the percent yielded here is going to be 76.6% yield in Fe2CO3, I'm running out of space in my little corner here, but that's what it is. 76.6% yield in iron 3 carbonate. That's how you calculate a percent yield.
So we did all that work to get to that.
Yes.
Just to get that in.
That's it. We did. Now listen. I'm sure there is. That's true. And here's why you can't use a computer program to find the answer for you. Because if computer programs aren't programmed properly, if you don't put in the right information, you're not going to get the right answer. And the only way you know if you're going to get how to get the right answer is to be able to do the problem yourself. Okay? Huh? Now look. This basically is the idea behind cost efficiency in business and industry. The higher your percent yield, the more stuff you're getting from the things you're buying, the more product you're making from the raw materials you have. Okay? If you want to run a business efficiently, you got to make product less expensively than the next guy, or certainly not more expensively than the next guy. Okay? If you can't, you're going out of business because you can't sell it for less money that way. You can't make any money that way. So if you can't find your percent yield, okay, you can't run your business. The problem number 2? Sure. All right, so first, before we go entirely to number 2, let me just make one thing clear. To find a percent yield, you need 3 things. You need an amount of reactant A, the first reactant in your problem. You need an amount of reactant B, and you need an actual yield. If you have those 3 things, you can calculate the percent yield. Okay? If you have those 3 things, you can calculate the percent yield. And in your lab, you measured out the amount of potassium nitrate you were starting with. You measured out the amount of was lead nitrate you started with, lead 2 nitrate you started with, and potassium iodide. So lead 2 nitrate, potassium iodide, there's your 2 reactants, and today you just weighed your product. You just found the actual yield. Now guys, I hope that you subtract the weight of the filter paper, because if you don't subtract the weight of the filter paper before you do your percent yield, you'll be getting a percent that's greater than 100, and you can't have a percent greater than 100. Okay? To have the actual yield, you only want the product, just the chemical. So I hope before you wrapped up your, before you actually filtered stuff last Friday, or Friday a week ago, I hope you weighed your filter paper, because that's the only way you're going to know what to subtract. If one piece of filter paper doesn't weigh, is what the next one does. Okay? So if you did everything you were supposed to do, you should have all the numbers you need. You were told to. I reminded you to verbally. I hope you got it somewhere in your lab notebook. Okay? All right. So if you didn't do the lab, you do this problem right here for homework. If you did the lab, you do the same thing, only for your lab results. Got it? Now listen. I want all your work on a separate sheet of paper for the lab. Okay? Then you're going to, when you get done, you're going to write in your lab notebook what your percent yield, what your limiting reactant is, what your theoretical yield is, and what your actual yield is. That's all you have to have. I'm sorry, your percent yield too. Those 4 things need to be written in your lab notebook. Okay? If you did the lab, yeah, you did the whole post lab. That's your homework. Okay?